Okay, so this one is a differentiation operator d by dx. We normally use it when you want to differentiate. Okay, so this is kind of representation which tells you that uh, the function which comes or the expression which comes after this you're just about to differentiate. Okay, so d by dx of, okay, so let's understand with an example. It could be like 5 times of, let's say, uh, I put this as f of x as of now. Okay, so this is what I'm going to differentiate. Okay, 5 dot, maybe I can put a dot. So f of x is multiplied with 5. So in this case what you do is you can just ignore the 5, or you can just simply take it out of the differentiation operator. So you don't have to differentiate that. So then you just have to differentiate only f of x. This is what constant multiple rule says. It's fairly simple. So 5 times of differentiation of f of x is f prime of x. Alright. Okay, we have a proof for this one. We can go through this. Okay, so whenever you want to prove, we have to use the concept of limits. So we know that the differentiation, that is f prime of x, this is basically a limit. Limit h tends to 0 here, or h approaches 0, fx plus h, f of x plus h minus fx all over h. Okay, so we can utilize this form, or you can utilize this form also. Sometimes in some textbook and some other context, it will be represented like this also. F prime of x equal to limit, instead of h you could utilize the delta x also. So delta x approaches 0, just replace the h with delta x. Fx plus delta x minus fx all over delta x. So this delta x represents a small change in x. Okay, just for the sake of proving this one. So we have two different kinds of definition. This is one, and this is exactly the same, just replacing the h by delta x. Okay, so let's utilize this and try to prove the constant multiple rule. So for example, okay, so then okay, so our f of x, so we can take our f of x is equal to 5 times of f of x. Okay, so this is our function now. Okay, so I'm going to find f prime of x for this one. So first derivative, this is equal to limit delta x tends to 0, f of x plus delta x. Okay, so I think this will be 5 will be multiplied here, c times of, yeah. Okay, so this one is 5, right? So x plus delta x 5 times minus, this is my f of x, 5 times of f of x all over delta x is equal to, okay, I can rewrite this as limit del x approaches 0. I can factor out 5 from this 2, then it will become 5 times of x plus delta x minus fx all over delta x. Okay, and in the next step, as you know that you can factor out the constant from the limits. So I can factor out the 5 times of limit del x times 0 fx plus delta x minus fx all over delta x. Okay, so this is equal to 5 times of, this is basically nothing but the definition of the derivative f prime of x. Okay, so if we have the function, if we consider this whole thing as our original expression or function, the derivative of this is 5 times of f prime of x. Right, this is very fairly simple. So in addition to that, what you have to know is, suppose if the constant could be, I can give some example for this one. So let's say you have to find the derivative of 5 times of x squared. Okay, So here you consider this as a constant. You can apply the constant multiple rule here. It's a product, right? These two are product terms. 5 times of x squared. This is basically nothing but 5 multiplied by x squared. Okay, so we have a constant here. I can apply the constant multiple rule, which means I don't do anything for this constant. I just keep the constant as it is and differentiate only the x squared, d by dx of x squared. We know what is the differentiation of x squared. We can apply the power rule. So 5 times of differentiation of x squared is 2x. Okay, so now you can multiply. 5 into 2 is 10x. So this is the final answer for this one. Understood this?
Yeah.
Okay, so in the same way, I can give one more example. Suppose if the constant is like a fraction also, if it is like 1 by 24, let's say x cube. Okay, here also I can consider this as a constant. This whole thing is a constant and this is the function or the expression. Okay, so I'm going to consider, I can apply the constant multiple rule here, which means I can keep the constant as it is and then differentiate only the x cube. So it will give me 3x squared. Okay, and finally you can simplify the terms, that is x squared over 8. So this is the final answer. So whether the constant is in the numerator or is just kind of fraction, you can simply take it out of the differentiation, differentiate only the function, which will give you the answer. So that's what it is given here. Whether it is c or whether it is 1 by c, you can simply take it out of it and then differentiate only the function.
I had a question. I had a derivative question in my homework for school that I think is related to this one. Is it okay if I just
Yeah.
give you the thing? You can help me
Okay.
Yeah, hold on one second.
Or you can copy paste here as well. If you have the material on your screen, you can simply copy and paste it here.
Okay, one second. Can I screenshot and copy and paste?
Yes.
Okay.